In the previous video, we discussed how to evaluate an infix expression, a prefix expression, and a postfix expression. This time, we're going to recall how we evaluate an infix expression and a postfix expression and compare the two. So let's use the example we have previously. Given this infix form, now how do we evaluate this? Recall that to evaluate an infix expression, we are to follow the MDAS rule. And the MDAS rule states that the first priority to be evaluated are the multiplication or the division. And second is the addition or subtraction. So what we do to evaluate an infix expression is to scan the arithmetic expression from left going right, and on our first scan left to right, we are going to execute or perform all the multiplication and division, and the order is whichever comes first from left to right. So in this case, this is addition, so we don't perform that yet, because on the first scan, we are going to perform only the multiplication or the division. So we ignore the addition and we go here. Next is multiplication. So we perform it. Now, since this is infix form, and if this is the operator, the left operand is on the left side of the operator, and the right operand is on the right side of the operator. So we perform this one, this becomes 8. And so the resulting value would now be 5 plus 8. Just bring down this one because the plus is not performed yet. And then next we encounter the minus, and again we ignore that because our priority is multiplication and division first. And then we reach this part, which is the division. We perform this. We get the left operand on the left side of the operator and the right operand on the right side of the operator. Thus, we perform 9 divided by 3. So this gives us 3, and bring down minus because that is not executed or performed yet. And then on the second scan, so this is our first scan. On the second scan, we have now this resulting infix expression. On the second scan, take note that only the addition and subtractions operators are left. Again, left to right, we encounter addition, so we get the left side and the right side of the operator as the left and the right operands. So we perform this. We now have 13 as the result, and then this is the resulting expression. So we encounter next is minus. We perform it. This is the left operand and the right operand. This gives us 10. Now we know that the value of this infix expression is 10. What if we have parentheses? What will happen if an infix form has parentheses? Because it is acceptable to have parentheses symbols in the infix expression, right? Now, say for example, we have here parentheses and also here. What will happen to the order of operators to be executed? Without parentheses, a while ago, the order of precedence or the order of operators to be performed are what? First is the multiplication, next is the division, next is the addition, and next is the subtraction. But this time that we have parentheses, we are going to perform from the innermost parentheses to the outermost parentheses, left to right, right? So the second characteristic of infix expression is that the MDAS rule is overridden by parentheses symbols. So the rule now when there are parentheses symbols is that you evaluate the expression in the innermost parentheses pairs going to outermost parentheses pairs. And you do that left to right. So like in this case, we now have parentheses. We enclose 5 plus 2 with parentheses pair, and 4 minus 9 with parenthesis pairs. So the order of operators to be executed would now be plus, and then the minus, and then the multiplication, and then the division. Okay? So innermost parenthesis first. So that would be 5 plus 2. That's 7 times 4 minus 9 is, that's negative 5. And then divide by 3. So this is an operand. And then after that, this is performed next and that. So 7 times negative 5, that's negative 35, divide by 3. Okay? So the value would be negative something. 35 divided by 3. It would not be 10. Okay? So it would not be 10 if we have this parenthesis. So the presence of parenthesis symbols would change the order of operators to be executed. Another characteristic of infix expression is that you scan the arithmetic expression left to right more than once. Okay? Like what we did a while ago. First scan, we execute or perform all the multiplication and division, whichever comes first from left to right. And then on the second scan, we perform all of the addition and subtraction, whichever comes first, left to right. So we scan the infix expression twice to completely evaluate it. So the third characteristic is it requires us to scan the arithmetic expression more than once. And the fourth is just by looking at the infix expression, like previously without the parentheses, just by looking at that infix expression, you cannot easily determine the order of operators to be performed. It is not automatic that the order of precedence, the order of operators to be executed, is first the plus, and then second the multiplication, third the subtraction, and then lastly the division. Okay? It's not left to right, the order of operators to be performed, but it depends on the MDAS rule. Okay? It follows the MDAS rule, and it would change also when there are parenthesis symbols. Like in the case of without parentheses, the order of operators to be performed is this one: first, second, third, fourth. But when there are parentheses, like if we have here parentheses, the order is no longer this one, but it would be this one. Okay, addition now is first, this is second, third, and this is fourth. It would change. So in an infix expression, you cannot easily determine the order of operators to be executed. So what if we convert this to postfix expression? This would now be 2, 4 times, and this is 9, 3 divide. So what's left is the plus and the minus. This is performed first before the minus. So this would be 5, left operand, right operand of the plus or addition. And this is the left operand and the right operand for subtraction. So minus is here. So the postfix is 5, 2, 4 times plus 9, 3 divide minus. The equivalent postfix expression is this one for the given infix. For our second stock application, we're going to discuss this algorithm that evaluates an input postfix expression and returns the numeric value of that input postfix expression. So again, the input to this algorithm is the postfix expression string, and let's try to use this postfix string here as the input to this algorithm, and this algorithm would output the numeric value of the postfix expression. Now, recall that this input postfix expression is equivalent to the original given infix. And we evaluate this a while ago and found that this infix expression has a value 10. So the output of our algorithm here must be also 10, since this input postfix expression is equivalent to this infix expression, which is equal to 10. Now, this algorithm makes use of one stack S, and we scan the input postfix expression left to right using a while loop. And for each iteration of the while loop, we get one symbol from the postfix. So this would be the first symbol on the first iteration. So symbol is 5. And on the second iteration, it would be 2. On the third iteration, it would be 4, and so on. So we scan the input postfix expression left to right, and as we scan it left to right, we get one symbol for every iteration. And as we get one symbol, we check if it is an operand or if it is an operator. If it is an operand like 52493, the algorithm would simply push that operand into the stack S. And if the symbol is an operator like multiplication, addition, division, and subtraction, it goes to this block of code. It performs the else block, in which we pop the top element of the stack and we assign it as the right operand, and we pop again the second time from the stack and we assign that value we pop from the stack as the left operand. So we pop two elements from the stack. The first pop is assigned as the right operand, the second pop value is assigned as the left operand, and then we call eval function, which is a user-defined function to identify what operator it is and then perform that operator on the two operands, which are this, the right operand and the left operand. And then this eval function will return the numeric value of evaluating the operator on the two operands. And it will be assigned to a local variable result. And then that value result will be pushed into the stack. And when we finish scanning the input postfix expression, that is when the while loop is over, we then display or output the only remaining element inside the stack. Now take note, when the input postfix expression is a valid postfix expression, then the stack S must have only one element left inside the stack when the while loop is over, or when we are done with scanning the input postfix expression. Again, stack S must have only one element left inside the stack, and that one element left inside stack is the numeric value of the input postfix expression. So let us now trace the algorithm. So say this is our stack S, and the first symbol we get from the input postfix is 5. Okay, symbol is equal to 5. And we go here to the if else. The symbol, which is 5, is an operand, so we push it into the stack. So we have here 5. After that, we go to the next or second iteration. We get the second symbol. This is equal to 2. So this time symbol is 2. And it is an operand, so we push it into the stack. So we have now 2 here. This is now the top element. And next symbol on the third iteration, the next symbol is 4. And this is an operand, so we push it again into the stack. So we have this one now, 4, as the top. So 4 now is the top element. Next iteration, the fourth iteration, symbol is asterisk. or multiplication, and it is an operator, so we perform this part. Right operand now, right op now is equal to, we pop from the stack, so 4 is removed and the new top is now 2. Okay, so we pop 4, so right op now is equal to 4, and then we pop again. Left operator is equal to, the second pop is 2, and we assign 2 to left operand. And then we call eval. So evaluate the symbol, which is asterisk, and the left operand is 2 and the right operand is 4. So eval would return 2 times 4, it would return 8. So result is equal to 8. And then we push the result, which is 8, into the stack. So recall that this is already removed. So the top now, after the 2 pop, the top now is 5. And when we push 8, we have 8 on top of 5, and that becomes the new top. After that, we proceed to the 5th iteration. And on the 5th iteration, the value of symbol is plus. It is an operator, so we execute this part again. So right up now, we pop from the stack, we remove 8, and so right operand now is 8, and this becomes the new top. And then second pop, 5 is removed and the stack becomes empty. So left op now is 5. And then we call eval, performing the symbol operator, which is plus. On the 2 operands, left operand is 5 and the right operand is 8. So 5 plus 8, eval would return the value 13. So result is equal to 13, and then 13, which is the value of result, is pushed into the stack. So what happens now is we have this removed already. We have now 13 inside, and this becomes the new top. Next iteration, symbol is equal to 9. And it is an operand, so we push that into the stack. So we have here 9 on top of 13, and this is now the new top. Next iteration, we get 3 as the value of symbol. It is an operand, so we push that into the stack. So we have here 3 on top of 9, and so this is the new top. Now stack S has 3 elements. Next iteration, we get divide or division symbol. It is an operator, therefore we execute this part. So we pop from the stack, we remove 3, and that is the right operand. And then second pop, we remove or we pop 9, and that is the value of the left operand. And so the new top is 13. We pop 3 and 9 already, and the new top is 13. After that, we call or execute this function eval, performing the symbol operator division on the left operand, which is 9, and right operand 3. So 9 divided by 3, that gives us 3. Result is equal to 3. And then result, which is equal to 3, we push that into the stack. So we have here 3 on top of 13. So this is now the new top. Now our stack S has 2 elements, and 3 is the top. Next iteration, we get the next symbol, which is subtraction. It is an operator, and therefore we execute this part again. So first pop returns to us this 3. Okay, so this is popped out. So the right operand now is equal to 3, and This is removed from the stack. 13 now is the new top. And then second pop, this is removed. So the stack now is empty. And the left operand is equal to 13. So the state of the stack now is that it is empty. After that, we call eval function performing the symbol operator minus on the two operands, which are the left operand is 13 and the right operand is 3. So 13 minus 3, the value returned by eval is 10, and that is the value assigned to result. And then we push result, which is 10, into the stack. So we have here 10, and this is the top of the stack. After that, we reach the end of the input postfix string. So the while loop is over, and we jump to execute this part, which is to display the only remaining element inside the stack, which is this one. That is our stack containing only one element, 10. This is now the numeric value of the input postfix expression. So you then output as that top, or depending on the programming language that you're going to use to implement this algorithm. So you follow the syntax of that programming language. Okay, so now we have verified that indeed this postfix expression has a value 10, the same as the value of the infix expression. So these two expressions, the infix and the postfix expressions, are equivalent, and therefore when evaluated, these two will have the same values.